Right now, as you're watching this video, there could be another version of you watching the exact same video, except they're eating pizza instead of scrolling through the comments. Actually, scratch that. There could be infinite versions of you. One where you're a billionaire, one where dinosaurs never went extinct and you're riding a T-Rex to work, and one where you decided to skip this video entirely. But let's be honest, that version of you is missing out. Welcome to the absolutely brain-melting concept of the multiverse, where reality isn't just stranger than we imagine, it's stranger than we can imagine. And before you click away thinking this is some Marvel movie nonsense, I need you to know that some of the smartest physicists alive are dead serious about this. So buckle up, because in the next 20 minutes, we're going to explore 10 mind-bending levels of the multiverse, and I promise you, you'll never look at reality the same way again. And hey, if you make it to the end, I'll tell you which level of the multiverse is most likely to be real. Let's dive in. Okay, let's start with the tamest version of the multiverse, which is somehow still completely insane. Imagine you're standing in the middle of an infinitely large, flat plane, like Minecraft, but without the edges. Now, here's the kicker. If space goes on forever, and there are only a finite number of ways that matter and energy can arrange themselves, then eventually, mathematically, everything has to repeat. It's like if you had infinite monkeys typing on infinite typewriters. Eventually, one of them is going to accidentally write the entire works of Shakespeare, and another one is going to write your embarrassing middle school diary. This is the level 1 multiverse, and it doesn't require any fancy physics or parallel dimensions, just an infinite universe, which many cosmologists think we actually have. So somewhere out there, beyond the observable universe, past the point where light has had time to reach us since the Big Bang, there's another Earth, another you, reading this exact script. Maybe they're better looking. Let's be real, they probably are. But here's what makes this deliciously weird. This isn't speculation or philosophy. If the universe is truly infinite and the laws of physics are the same everywhere, this is just math. Boring, inevitable, I can't believe it's not science fiction math. You've got cosmic doppelgangers out there, and they're probably also procrastinating on YouTube right now. The observable universe contains about 10 to the power of 90 particles, which means there are only so many ways those particles can arrange themselves before the patterns start repeating. So if you travel far enough, we're talking 10 to the power of 10 to the power of 29 meters, give or take, you'd theoretically find an exact copy of our observable universe. Same Earth, same you, same weird stain on your ceiling you keep meaning to clean. Welcome to level 1. Where infinity makes reality photocopier level redundant. Now let's rewind to literally the beginning of everything, about 13.8 billion years ago, when the universe decided to throw the most explosive party in history. We're talking about cosmic inflation, and it's the reason we're here to even have this conversation. In the first tiny fraction of a second after the Big Bang, we're talking 10 to the power of -36 seconds, the universe expanded faster than a rumor in a high school hallway. We're not talking about gradual expansion here. Space itself was stretching faster than the speed of light, inflating by a factor of at least 10 to the power of 26 in less time than it takes you to blink. This isn't science fiction. This actually happened, and we have evidence for it in the cosmic microwave background radiation, which is basically the universe's baby photos. But here's where it gets multiversy. Inflation solves some massive problems in cosmology, like why the universe looks the same in every direction, and why it's so incredibly flat. It's like someone hit the smooth button on reality itself. The crazy part? Most versions of inflation theory suggest that once inflation starts, it never completely stops everywhere. It keeps going in some regions of space, creating bubble universes while slowing down in others, like ours, where galaxies and stars and you can form. Inflation is the engine that could be manufacturing universes like a cosmic factory that never closes, churning out reality after reality in an eternal, never-ending process. And the physicist Alan Guth, who came up with this theory in 1980, has called inflation the ultimate free lunch because it creates entire universes out of essentially nothing. So yeah, cosmic inflation, the theory that explains why our universe is so weirdly perfect for life, and also why there might be infinite other universes where everything is completely different. So inflation is happening. Space is stretching like cosmic silly putty, and then pop! In some regions, inflation stops, and a bubble universe is born. Congratulations, you've just been promoted to level 2 of the multiverse. This is where things get properly weird, because we're not just talking about distant copies of our universe anymore. We're talking about universes with potentially different laws of physics. Imagine bubble universes floating in an eternally inflating background like bubbles in a cosmic foam bath, except instead of rubber duckies, each bubble contains an entire universe with its own physical constants, its own particle physics, maybe even different dimensions. In one bubble, electrons might be heavier, making atoms impossible. In another, gravity might be stronger, causing every star to collapse into a black hole immediately. Our bubble just happens to have the Goldilocks conditions, where galaxies form, stars shine for billions of years, and complicated carbon-based life forms can evolve to argue about politics on the internet. The spaces between these bubbles? Still inflating, still creating more bubbles in an infinite cascade. You can't travel to these other bubble universes because they're causally disconnected from us. The space between is expanding faster than light, which is the universe's way of saying, you can't get there from here. Physicist Alexander Vilenkin has calculated that eternal inflation produces not just many universes, but infinitely many, with every possible variation of physical laws and constants. And the beautiful part? Each bubble universe thinks it's alone, that its laws of physics are the laws of physics, just like we do. We're all islands of stability in an ocean of chaos, convinced we're the only land in existence. Level 2 multiverse, where our entire reality is just one bubble in an infinite cosmic foam party. What if I told you the Big Bang wasn't the beginning, but just the latest in an infinite series of cosmic reboots? Welcome to the cyclical multiverse, where universes bounce back like a cosmic yo-yo with commitment issues. This idea has ancient roots. Hindu cosmology has been talking about infinite cycles of creation and destruction for thousands of years, but modern physics is giving it a serious upgrade. The basic idea is this: our universe expands, cools down, eventually either collapses back on itself in a big crunch or hits a minimum energy state, and then bang, it bounces back and starts over, rinse and repeat, forever. One version of this, proposed by physicists Paul Steinhardt and Neil Turok, involves brains. These are like multi-dimensional membranes floating in higher dimensional space, because of course they are. When two brains collide, bam, you get a Big Bang event. Then they drift apart and eventually collide again. Each collision creates a new universe with potentially different properties. It's like the most violent game of cosmic ping pong ever, except instead of a ball, its entire universe is being created and destroyed. Another version involves quantum mechanics saving the universe from total collapse. Right before everything crunches into a singularity, quantum effects kick in and cause a bounce that starts a new expansion phase. What's cool about cyclical models is they solve the what came before the Big Bang problem by saying there is no before, just an eternal cycle with no beginning or end. The laws of physics might reset slightly with each cycle, meaning each iteration of the universe could be subtly different. Maybe in the last cycle, coffee tasted like orange juice. Tragic timeline, really. The cyclical multiverse is philosophy's eternal return meeting cutting-edge physics, suggesting that even the universe itself can't escape the loop of existence. Hold on to your brain cells because we're about to talk about how black holes might be giving birth to baby universes. Yes, you heard that right, black holes as cosmic maternity wards. This is the fecund multiverse hypothesis proposed by physicist Lee Smolin, and it's based on a beautifully wild idea. Every time a black hole forms, it creates a new universe inside itself, complete with its own space-time that's completely cut off from ours. From our perspective, all the matter that falls into a black hole is crushed into oblivion at the singularity. But from inside, that singularity might be the Big Bang of a new universe, expanding in its own private space-time that we can never access or observe. It's like reality has a maternity ward we can never visit because it's behind an event horizon. Now here's where it gets even crazier. Smolin suggests that these baby universes inherit the physical constants of their parent universe with slight mutations like cosmic DNA. Universes that produce lots of black holes will spawn more offspring, which means natural selection applies to universes themselves. Over countless generations, universes evolved to be really good at making black holes, which coincidentally requires stars, which coincidentally requires conditions suitable for complex chemistry, which coincidentally is what we observe. It's anthropic reasoning with a Darwin twist. Our universe might be fine-tuned for life not because of divine intervention or dumb luck, but because it's descended from a long line of successful universe reproducers. We're the products of cosmological evolution. Every stellar mass black hole, every supermassive beast at the center of galaxies, each one might be a portal to a new reality, a new experiment in physics and existence. The fecund multiverse turns black holes from cosmic dead ends into cosmic nurseries, suggesting that reality itself has figured out how to reproduce. All right, time to talk about string theory, which is either the most elegant solution to quantum gravity or the most elaborate mathematical fantasy ever conceived. Physicists still haven't decided. String theory proposes that the fundamental building blocks of reality aren't particles, but tiny vibrating strings of energy. Different vibration patterns create different particles, like cosmic guitar strings playing the song of existence. Cute metaphor, right? But here's where it explodes into multiverse territory. String theory requires extra dimensions, not just the 3 spatial dimensions and 1 time dimension we're familiar with, but up to 11 dimensions total. These extra dimensions are curled up so small we can't see them, but the exact way they're curled up determines the laws of physics in that universe. And there aren't just a few ways to curl up these dimensions, there are approximately 10 to the power of 500 possible configurations. That's more possible universes than there are particles in our observable universe, by a lot. This enormous number of possibilities is called the string theory landscape, and each valley in this landscape represents a different universe with different physical laws, different particle masses, different forces. Our universe is sitting in just one of these valleys, but all the others might exist as separate bubble universes in the level 2 multiverse. Critics call this the landscape problem, because a theory that predicts everything predicts nothing. You can't test it if any observation can be explained by, well, that's just the universe we happen to live in. But proponents argue it explains the seemingly arbitrary values of physical constants in our universe. They're arbitrary because they're randomly selected from the landscape, and we exist in one that allows life because, well, we wouldn't be here to ask the question otherwise. The string theory landscape transforms the multiverse from a dozen possibilities to a number so large it makes infinity jealous, suggesting that reality is exploring every possible mathematical variation of existence simultaneously. Let's pivot to quantum mechanics, which is hands down the most successful theory in physics and also the most philosophically disturbing. At the quantum level, reality behaves like it's had way too much coffee and can't make up its mind about anything. Particles exist in multiple states simultaneously until observed. They're waves and particles here and there, spinning up and down all at once. This is called superposition, and it's not a metaphor or approximation. It's literally how the quantum world works. When you measure a quantum particle, it collapses into one definite state, but before measurement, it genuinely exists in all possible states at once. Schrödinger's cat, simultaneously alive and dead in a box, wasn't meant to be a fun thought experiment. It was Schrödinger saying, "Look how absurd this is." Except the universe said, "Yes, exactly," and kept doing it. The famous double-slit experiment shows that a single photon can go through two slits at once, interfering with itself like a wave. But the moment you try to detect which slit it went through, it picks one and acts like a particle. It's like reality is playing an elaborate prank where it only becomes real when someone's watching. Einstein hated this. His famous line, "God does not play dice," was him objecting to the inherent randomness of quantum mechanics. But the experiments kept proving quantum mechanics right. We've built computers, lasers, transistors, and MRI machines based on quantum mechanics. So whatever philosophical weirdness it implies, it works. But here's the thing. Quantum mechanics tells us how the quantum world behaves, but it doesn't tell us why. What causes the collapse? Why does observation matter? And most importantly for our purposes, what happens to all those other possible states when a measurement is made? Do they just vanish, or is something else going on? This is where interpretations of quantum mechanics diverge, and where one particular interpretation leads us directly into, here it is, the interpretation of quantum mechanics that keeps physicists up at night and science fiction writers employed forever. The many worlds interpretation, proposed by physicist Hugh Everett in 1957, says that quantum superposition never actually collapses. Instead, every possible outcome of every quantum measurement actually happens in separate branching parallel universes. When that quantum particle could go left or right, the universe literally splits into two branches, one where it went left, one where it went right. Both are equally real. Both contain versions of you, and both continue evolving independently forever. Every quantum decision, every random event, every coin flip at the atomic level creates a new branch. And since there are approximately 10 to the power of 90 particles in the observable universe, all constantly interacting and creating quantum events, the universe is branching an absolutely incomprehensible number of times every fraction of a second. In some branch, you took that job offer. In another, you didn't. In one branch, you're a millionaire. In another, you're broke. In one branch, you decided this video was boring 3 minutes ago. In another, you're obsessed and taking notes. The Level 3 multiverse isn't about distant regions of space or bubble universes. It's about reality itself constantly splitting into parallel versions, all coexisting in some higher dimensional Hilbert space, where all possibilities are real. The mind-blowing part, this interpretation requires no additional assumptions beyond the standard equations of quantum mechanics. It just takes them seriously and follows them to their logical conclusion. No collapse, no observer effect, no magic, just pure deterministic branching. The many worlds interpretation is either the most elegant solution to the measurement problem in quantum mechanics or the most extravagant ontology ever proposed, depending on who you ask. But here's what keeps me up at night. If it's true, then free will is weird, because every choice you could make, you do make in some branch. You're living out every possible version of your life simultaneously across an infinite tree of branching realities. Okay, we've officially reached the I need to lie down level of the multiverse hierarchy. Physicist Max Tegmark's Level 4 multiverse proposes something so philosophically radical it makes everything else look tame. Every mathematically consistent structure exists physically as a separate universe. Not could exist, does exist. If you can write down the equations for it without contradictions, it's real somewhere. A universe where 2 + 2 = 4 exists, but so does a universe where the rules of arithmetic are completely different. A universe with 3 time dimensions. A universe where space is fractal. A universe governed by Conway's game of life. If it's mathematically possible, it's physically real. Why? Because according to Tegmark, mathematical existence and physical existence are the same thing. Our universe isn't just described by mathematics, it is mathematics. We're patterns in a mathematical structure having experiences. And if our mathematical structure exists, then by what criteria could we claim other mathematical structures don't? This is called the mathematical universe hypothesis, and it suggests that asking why these laws of physics and not others is like asking why does the number 7 exist? It exists because it's mathematically coherent, and all coherent mathematical structures have equal claim to existence. The Level 4 multiverse contains not just variations of our universe, but completely alien forms of existence that follow entirely different logical rules. Some might not have space or time as we understand them. Some might not have particles or fields. They'd be so fundamentally different that universe might not even be the right word. And yet, if Tegmark is right, they're all equally real, all existing in some abstract Platonic space of mathematical possibility. This is where physics meets pure philosophy, where asking what is real becomes what is mathematically possible. It's either the deepest truth about existence or the point where physicists should have stopped and gone outside for a walk. And now for the multiverse hypothesis that's definitely going to ruin your day. What if our entire universe is a simulation running on some advanced civilization's computer? Welcome to the simulation hypothesis, popularized by philosopher Nick Bostrom in 2003, which belongs to Level 4 because it suggests our reality is generated by computation, just another mathematical structure being executed. Here's Bostrom's argument. If any civilization reaches the technological capability to run detailed simulations of universes with conscious beings inside them, they'll probably run lots of them. Why run one when you can run millions? And if advanced civilizations run millions of simulated universes, then there are vastly more simulated consciousnesses than real ones. Statistically, you're more likely to be in a simulation than in base reality. The math is brutal. If even 1% of advanced civilizations run simulations, and they run an average of 1,000 simulations each, then for every real person, there are 10 simulated ones. Your odds of being in base reality? 9%. Welcome to existential roulette. And before you say, "But I feel real," so would a simulated consciousness by definition, or the simulation would be poorly designed. The weird part is, this ties back to all the other multiverses. Whoever is running our simulation might be in a simulation themselves, and that civilization might be simulated too. It's simulations all the way down, or rather, all the way up. We could be nested inside layer after layer of simulated realities with no way to ever reach the real bottom. Some physicists have proposed ways to test this, looking for glitches in physics, computational artifacts in the fabric of space-time, evidence that reality has a finite resolution like pixels on a screen. So far, nothing conclusive. But here's the kicker. If we're in a simulation, the multiverse might be just different save files or different servers running variations of the same program. Every time you restart a video game, that's a new universe for the characters inside it. Are we just someone's Sims file left running while they go to work? So, after all that cosmic insanity, which level of the multiverse is most likely to be real? Honestly, probably some combination. The level 1 infinite cosmos is just geometry. Level 2 bubble universes follow naturally from inflation, which we have evidence for. Level 3 many worlds is just quantum mechanics without the collapse. Level 4 gets pretty philosophical, but hey, math has a weirdly good track record of describing reality. And the simulation hypothesis? Well, that one keeps me up at night more than I'd like to admit. Here's what absolutely blows my mind. Every single one of these multiverse theories was developed by serious physicists and mathematicians trying to solve real problems in cosmology and quantum mechanics. Nobody set out to prove infinite realities exist. They were just following the math and the evidence, and the multiverse kept showing up like an uninvited guest at a party who turns out to be fascinating. Whether we live in a multiverse or not, the fact that we can even ask these questions, that we can use math and physics to probe the deepest nature of reality, is kind of miraculous in itself. So maybe there's a universe where you didn't watch this video, but in this one, you made it to the end, and I appreciate you for that. Now here's what I need from you. Smash that subscribe button, because in at least one parallel universe, you already did. And that version of you is having way more fun. And here's the real question I want you to answer in the comments. If you could meet one alternate version of yourself from any of these multiverse levels, which universe would they be from, and what's the first question you'd ask them? Would you meet the billionaire you, the one who became an astronaut, or maybe the one who made that risky decision you chickened out on? Drop your answer below, because I'm genuinely curious what everyone would choose. Thanks for watching, and welcome to the multiverse. Population, yes.